Greetings and welcome, friends. Happy day, chapter 3. We are here. We're talking about lines, friends. And today we're specifically talking about parallel lines and pairs of angles and the sort. So let me just jump right in. We've got a bit of vocabulario for you, but don't you worry. It's going to be amazing. You're going to be able to know how to talk about things and read about things and draw things. It'll be wonderful. And all of these words, even if I was to, for instance, not directly assess you on them later, like do you know the definition of parallel planes or something, you would still need to know what these words mean in order to correctly interpret the questions I would ask. And of course, because this is geometry, we will eventually be doing proofs with all of these definitions and properties. So we kind of want to add these to our mental toolbox of proof-sufficient reasons. So let's see, parallel lines, skew lines, and parallel planes. Two lines that do not intersect each other are either parallel lines or skew lines. All right, two lines are parallel when they do not intersect and are coplanar. Okay, that's pretty key right there. You guys have seen parallel lines before, back in the days of Algebra 1-dom. And two lines are skew when they don't intersect, so they have that in common, and are not coplanar. Also, two planes that do not intersect are called parallel planes. Wow, good stuff. Wonderful, wonderful. So let's see, here in this little diagram, it says lines M and N are parallel lines. Notice two things you should be aware of. This symbol here, the double parallel line, double absolute value, super skinny sort of symbol going on here, that means parallel, friends. And in the diagram, having two arrows suggests parallelity as well. That is not a word to my knowledge. Which, by the way, actually, let me draw a little sample parallelogram here. So if I draw, you don't have to draw like full closed shaded in triangles. So these two sides are parallel. And if I wanted to suggest that these pair of sides were parallel, I would label them with a different number of arrow tick marks. Okay, so the ones with double arrows are parallel, the ones with single arrows are parallel, but they are not all parallel to one another. Okay, so a couple new pieces of notation there was the double bar parallel line notation. Remember, we also had the upside down T for perpendicular, so there's that. Let's see, lines M and K are skew, so there's line M, line K is here. They are not coplanar. They are non-intersecting. They are parallel. Whoop, whoop. There we go. It says planes T and U are parallel planes. Planes, notice, are denoted with capital letters. These are parallel planes. They never intersect. Okay, so you have to imagine these planes going infinitely in all directions. I would also point out that any line on plane U is going to either be parallel or skew to any line on plane T. All right, and there would actually be infinitely many lines on plane U that are parallel to, say, line M, right? But there are also infinitely lines on plane U that would be skew to line M. All right, so interesting stuff there. Okay, then it talks about the small arrows and segments, and I think I've got all that explained. So let's keep rolling here, friends. Oh, we got an example. I'm so excited. Guys, are you excited? I'm excited. I'm pumped up. Parallel. Here we go. Identifying lines and planes. Think of each segment in the figure as a part of a line. Oh, okay. I just did that. So like segment CD, they actually drew the line CD that continues infinitely. Which lines or planes appear to fit the description? Lines parallel to CD and containing point A. So here's point A. How many lines are parallel to CD that pass through point A? What would its name be? Looks like, yeah, line AB. All right, I like it. I like it a lot. So yeah, that looks like the only one. I don't think I can imagine another one that is parallel that passes through that point. That point kind of narrowed things down for us, notice. Let's see, Lines skew to CD and containing point A. Let's see, how about some skew lines? What do we got, Nordheim? I'm sorry, I said your name on the internet. Oh, man. That's all right. Don't worry. I'm sure there's plenty of you guys out there. So let's see. What was your response? AG, I think, is a good one. AG. Any others, friends? AH. Yeah. Yeah, I think so. And then theoretically, you could imagine infinitely many lines that, you know, would pass through a point somewhere in between H or G if we had names for it, but we don't. So those ones will suffice. Man, do you guys like Vocab Day? I feel like in some ways it's just kind of easier. I don't have to like synthesize ideas and figure them out. I'm just like, what's this word? How does it relate to this diagram? It's like kind of easy, but then also a large volume of material that I now have to become familiar with. Let's see, lines perpendicular to CD containing point A. DA? Did I hear DA? I think so. I'm calling it. We'll call it correct. I like it. Perpendicular. Also, yeah, notice the perpendicular symbol here. I like it. Line, duh. And lastly, planes parallel to EFG and containing point A. So EFG is the bottom of the box. What is a parallel plane? What are our thoughts? Yeah, any way to describe this top plane? Yeah, using 3 of the 4 letters described. It's probably a good idea to include point A since they wanted to reference that. So yeah, I'll just call it. How about plane bad? All right, so it's just plain. Yeah, that works. Or CAB. It's all the same plane. They're just different names for it, though. So here we go. All right, guys. Whoa, we got some postulates, friends. Are you ready for this? All right. Put these into your brains, friends, so you can recall this information whenever you are writing a proof and you're trying to justify your statement. Postulate 3.1, the parallel postulate. If there is a line and a point not on the line. I like that beginning. Imagine a line. Now imagine a point not on the line you were just imagining. Then there is exactly one line through the point parallel to the given line. Okay, so there's only one line that I could ever draw that meets both of those conditions simultaneously. All right? All right, you guys, do you believe that? Does that seem feasible? It's a lie? Tell you what, whoa! All right, let's draw a line here. And let's see, I'll label some points. A, B, and let's label it C. I'm not a musician, I'm assuming those are right. And now check this out. This is a geometer sketchpad in case you're wondering. So these points are unrelated to each other. And if I select point C and line AB, I can go to construct parallel or perpendicular line, and it will construct it. And watch this. No matter which way I drag it, this new line that I just made is forever parallel. Whoa, crazy sauce, right? How great is that? I can't cross the lines. I could make them coincident, so they're either hitting all the time or never. Yeah. Guys, I feel like this is like synchronized swimming or something. Yeah, there we go. So notice there's only ever one line that will be parallel that passes through that point, no matter how I imagine these existing. All right. So that's the parallel postulate. Perpendicular postulate. Oh, you don't say. It turns out there's also only one line that is perpendicular to a given line and a point not on that line. You guys believe it? Do you believe it? I mean, granted, like my little geometer sketchpad example isn't necessarily a proof. It's just kind of like gives us a series of case studies of like, okay, all right, that seems to make sense, right? Let's label my point. Notice how I'm doing this. I go to the selection tool. Watch this, multitasking. Whoa, bam! See how I just grabbed that? I selected both the point and the line. I don't want to have one of these points selected. That would not be good. Oh, did you like that? I just like made that blow up, didn't I? Bam! That's for transformations and rotations and dilations later. So let's see if I construct a perpendicular line. Notice no matter which way I draw it, there's only one line that could ever fulfill that condition. We could even then notice how when I place this point, snap it to both of those simultaneously. And let's actually measure this angle. Let's measure the angle B. I'm guessing it's going to label this DC. And if I go to measure angle, 90 degrees, no matter which way I draw it, it's always 90 degrees. Wow, I like that. Whoa, I can like, if I figure eight, that's pretty crazy. What? Wow. Anyways, there you go. So perpendicular line postulate, or perpendicular postulate. Yeah, there's only one. There can only be one. So let's do an example. Ooh, guys, I'm excited about this. Man, I think I'm just pumped about all of this. It must have been that pep rally that done did this to me. I'm just like, geometry, yeah! Yeah, I mean, we should have a geometry team here at our school. You guys would all be on it. Okay, so you guys have this on your paper already. So check this out. This looks like some sort of location, a map, perhaps. I wonder if this is a real location. Theoretically, we'd be able to like compare some of these numbers. I don't know. We could probably figure this out if this is an actual location in the universe. It reminds me of when Google, I don't know, Isaiah, if you knew this, when Google Maps actually had the Pac-Man add-on that you could actually take Google Streets and turn them into Pac-Man lanes with power pellets, and you could like have Pac-Man run around the streets of your hometown. It was pretty amazing. I was a fan. I don't know about you guys. Good old Google. I like Google. Let's see. Name a pair of parallel lines. Okay, let's see. What are your guys' thoughts? Parallel. Yes, Mr. Mysterious.
BC and FB.
BC?
No, EC.
EC and FB. Let's see. Do I know that yet? These arrows are referring to the ends of the lines going forever. Did they label these? They look parallel.
Then we can just do D, A.
I believe it's called duh. I'm just kidding. Sorry. Right? Looks like, yeah, duh and fee. Yeah. Yeah, duh and fee. Those are labeled with the double arrows indicating parallelacity. Right? Are you with me, Aiden Diamonds? Looks like you're purchasing some backpacks or something. No? All right. So these are parallel. Now, if I had some more information, for instance, if I knew that this was perpendicular and the fact that these would both be perpendicular, there will eventually be a theorem that says that those two would have to be parallel. But right now, it wasn't labeled for me, so I'm going to assume that it is not the case. All right, let's look at B here. Name a pair of perpendicular lines, and there's only one that we know of, so we'll call it duh and boof. There we go. All right, so line DA and line BF are perpendicular to each other. I don't have the information about the other ones yet, so I can't help you out. Let's see, C. Is FE parallel, that's our new symbol, parallel to AC? Explain. So let's see, FE parallel to AC. Now you guys are probably with me, you're like, that doesn't even look parallel. And I would agree. So I'll say no, but our reasoning might be different. Notice that AC intersects at point M with DA, and if they intersect at only one point, and I know that DA is already parallel to this one, the only way a line could pass through that point and be parallel to this is if it was the same line, right? That was the parallel postulate that says there can only be one line that passes through a given point that is parallel to another. And so I can't just suddenly have like two lines that pass through that point and are parallel. So my answer is no, because it would have to have been the same line as DA, and it is not. There's my verbal explanation. I'm not going to write that down. I'll let Google Subtitles do that for me. Question, comment? That symbol is parallel. That symbol right there? Yeah, it's like two parallel lines, yeah. Yeah, it's one of those times when the symbol makes sense. Yeah. Let's see, here's a new word, a transversal. Transversal is a line that intersects two or more coplanar lines at different points. Now that's kind of would seem like an arbitrary line. Why would I ever care about a transversal line? But it turns out there's some interesting behavior when I'm that specific that I can then begin to describe and discover all sorts of properties of. Okay? So we're going to talk about angles formed by transversals. Tomorrow, I believe, we're going to talk about specifically parallel lines. Oh, good call. Man, always got my back, helping me out. Faithful are the wounds of a friend, deceitful are the kisses of an enemy. You're a friend enough to me that you tell me when I'm wrong, and I appreciate that. I appreciate that. So yeah, Monday we'll be talking about parallel lines cut by a transversal. Today we're just talking about transversals, okay? Transversals. Let me actually, I'll even put these other two cases here. I couldn't fit it all in one snapshot and get the resolution that I wanted. So I'll just piecemeal this up here. All right, here we go. Do you think I can line that up? Line it up. That's pretty close. That'll do. So, angles formed by transversals. Corresponding angles. Two angles are corresponding angles when they have corresponding positions. That seems like not a definition since you're using the same word. But corresponding angles, notice that I've got two intersections here, right? Two intersections. And the northeast quadrant, so to speak, of each of those intersections are angles 2 and 6. Those are corresponding angles. That from the perspective of those intersections, they're in the same quadrant, so to speak. So these are kind of, right, northeast angle for both of those. Other corresponding angles would have been, for instance, this angle and this angle, which are currently not labeled, okay? So angles that are in the same quadrant with respect to their intersections when they are cut by a transversal are corresponding angles. Those angles are going to be a basis for a lot of our arguments and proof coming up. Let's see, alternate interior angles. All right, AIA, alternate interior angles, okay, are on alternating sides of the transversal. Notice they're on different sides. And they're inside the interior. Okay, here's the interior piece. They're inside, right, Isaiah, of those two lines. And they are on alternating sides of the transversal. Okay, so they're on different sides of the transversal. Those are alternate interior angles. There are multiple alternate interior angles. So angles 4 and 5 are AIA, as well as this angle here and this angle there would be alternate interior angles. Okay, alternate exterior angles. Notice here's the alternate concept again. They're on differing sides of the transversal, and they're exterior angles because with respect, yeah, don't go through my stuff there, Isaiah, of the, I thought you were going in my drawers there. I've taken out most of the important stuff in there, at least. Yeah. But they're on the exterior of those two lines, right? They're outside. They're not within those two lines. So those are alternate exterior. Another pair of alternate exterior angles would be like if I called this angle 7 and angle 2. Angles 7 and 2 are alternate exterior angles. Wow, guys, you're figuring this out, right? This is making sense? Super easy. Consecutive means they're on the same side of the lines cut by a transversal, and interior angles because they're in between. Now, the only one they didn't bother naming was consecutive exterior, but I think you guys could imagine what those look like if you wanted. And in this case, let's see, angles 4 and 6 would be consecutive interior angles to one another. All right, so eventually we're going to have all sorts of information that we will be able to discern about parallel lines cut by a transversal. But today we're just learning the names of things and learning how to identify things. Okay, here we go, friends. Are you with me? All right, example 3. You guys got this. Identify all pairs of angles of the given type. Corresponding angles. All right, what is a corresponding angle to angle 1? Yeah. Nordheim. Angle 5, perfectly. Perfectly executed. What's a corresponding angle to angle 2? Someone else. Angle 6. So angle 2, angle 6. All right, I kind of have to like, yeah, whatever. That's fine. I'm fine with this. I should probably write and between these, but you get it. You get the idea. Corresponding angle to angle 3. All right, you guys are experts here. Also, ooh. Oh, I should actually not label them as such anymore because these two I don't know are congruent unless those are parallel. Oh man, that's super wrong. Wrong information. I gotta undo it the whole way. I can't undo it anymore. No! How sad. And I'm writing on the same layer as the drawing itself. Actually, wait a minute. You know what? Bam. No one knows. No one knows. Your minds have been erased by some sort of Men in Black pen flashy thing. You don't remember this anymore. But everyone remembers Men in Black. Everyone does. So corresponding angles, I'll just, angle 1 and angle 5 are corresponding, angle 2 and angle 6, angles 3 and angle 7, and angles 4 and angle 8, right? Because those are the southeast quadrant for both of their intersections. Does that make sense? Corresponding? I like it. Alternate interior. What's an alternate interior to angle 2? Alternate interior, anybody? Rescue. Someone help us. Angle 7. There's only one other that would work. So angle 2 and angle 7. What is another pair of alternate interior angles? 5 and 4, okay? 5 and 4 are alternate interior angles. Okay, let's see. Alternate exterior. What's the alternate exterior to angle 1? 8. I like it. And what's the other pair of alternate exterior? 3 and 6. Good call. And consecutive interior? 4 and 7. I like it. Yeah, same side interior angles. And what's the other pair? 2 and 5. You guys are experts at this. Question, what's a vertical angle to angle 1? Angle 4. What's a linear pair to angle 1? Angle 2 or 3. I like it. Okay, yeah. That's some callbacks there, some flashback information there for you. Let's see. Let's just do these last 3 examples, and we are golden, friends. We're going to be good. Where's my scroll bar? There we are. Okay, here we go. Can someone classify angle, problem 3, angles 1 and 5? Yeah, Aiden. Those are corresponding angles. I like it. All right, let's see, Isaiah. Question 4, angles 2 and 7. They're exterior and they're alternate. I like it. And let's see. Let's have Anthony. Question 5. No? Actually, it's hard to tell. This is like a small sketch. I believe they're talking about these two angles here. They are interior. And are they same side, like, or are they alternating? They're alternating. So alternate interior angles. So guys, this isn't that bad, right? This is el más fácil del mundo. I think so. Oh, I forgot that I can hit the tab button to get rid of my inkwell. Well, anyways, thank you for watching, Internet friends. Have a great day.